Welcome to my project bazaar.com. Now let's see the title of our project. Local Tetra patterns, a new feature descriptor for content-based image retrieval. This is the title of our project. Now let's see the abstract. Here the image retrieval process will be carried out by many ways. Now we are going to see about the image retrieval by means of local Tetra patterns. So we propose the efficient framework which deals with the image indexing, which is carried out by the local Tetra pattern generation. So by generating the local Tetra patterns of the image, we can able to retrieve the images from the image rich environment in a most efficient manner. So in existing system, the image retrieval can be carried out by the local binary patterns, which deals only with the horizontal as well as vertical direction analyzation. So the existing local binary pattern image retrieval will not be effective. So in order to overcome those processes, proposed the efficient algorithm by generating the local Tetra pattern. Here we formulated the image into a matrix by means of direction in which the further analysis will be carried out will be depends upon the referenced pixel. So putting the image into a matrix format, we will be getting one reference pixels. Based on the reference pixel, we can able to calculate the histogram of the images. So after computing the histogram of the images, we can able to determine the feature vector of the image. So we will be getting some kind of values for the input image. So depends upon the distance as well as the histogram value, the analysis of the process will be carried out. So for calculating distance of the image, we will be using the Euclidean distance. So after the so by a local Tetra pattern, we computing the n-1th order of the horizontal direction, vertical direction as well as the diagonal direction. That is, we will be analyzing the image by means of every direction. So by implementing the automated system which implements the local Tetra pattern for the image retrieval, the retrieval of the image will be of more accuracy, whereas in existing system the image retrieval will be of less accuracy than expected. So here we converting the input image into 5x5 matrix format, in which we can able to determine the reference pixel. Analysis of the reference pixel, the Euclidean distance will be carried out. After the completion of that, the histogram of the images will be calculated. So after the calculating of the histogram, the feature vector value of the image will be get calculated. This is the data flow diagram of our project. As I said, first we need to generate the local binary image. In this local binary image, it will be carried out by converting the input image into 3x3 matrix. After acquiring the local binary pattern, we need to generate the local ternary pattern. The local ternary pattern slightly differ from the local binary pattern by means of some grayscaling and threshold effect. So matrix. After the generation of the local ternary pattern, local Tetra pattern will be generated. The local Tetra pattern of the input image will be generated by converting the input image into 5x5 matrix. After the conversion of the image into a matrix, the reference pixel will be get calculated. By related to the reference pixel, the Euclidean distance will be carried out in order to determine the distance. So based on the distance, the annotation will be continued. So after computing the distance, we will be calculating the histogram values. After acquiring the histogram values, we need to generate the magnitude local Tetra pattern, which is efficient from the local Tetra pattern. Here the feature vector of the every image will be get calculated. So after the generation of the magnitude local Tetra pattern, the feature vector generation will be taking place, by which we can able to retrieve the similar images from the image rich database. After acquiring the feature vector of the image, we need to compare the input image as well as the every images in the database. Then for every images in the database, the overall process will be carried out again. After that, based on the feature vector of the input image as well as the feature vector of the image which is present in the database, we can able to do the comparison. After the comparison, we can able to retrieve the most accurate image as well as the most similar image from the database. Now let's see the demo of this is the home screen of our project. As I said, first we need to generate the local binary image. After select, this will be the input image for which the database for which we gonna search for which we need to search the most accurate image from the database. Let's generate the local binary image. This is the binary image pattern which is generated for the input image. Now let's proceed with this. We need to retrieve the similar image for this local binary pattern in order to determine the accuracy lag in this local binary image. Now let's see. These are the images that is retrieved for this local binary pattern which have the some unrelated images. That is, the accuracy will be less in this by generating the image by the local binary pattern. Now let's proceed. Now we need to generate the local ternary pattern which is derived from the local binary pattern. At first we need to generate the local binary pattern. From this local binary pattern we can able to generate the local ternary pattern. Now let's proceed. Now we are going to search the similar image for this local ternary pattern image from the database. These are the similar images for this local ternary pattern image. The image by the local ternary pattern. Here we need to generate the local tetra pattern. Now we are going to search the similar image from the database for the local tetra pattern image. These are the similar. ஆமா சார் அப்படியா ஓ these are the similar image retrieved for this local tetra pattern image. These are the top 20 related image for this local tetra pattern image. Now let's proceed. Now we are going to generate the magnitude local tetra pattern image. Every image that images. Now we are going to retrieve the similar image from the database for this magnitude local tetra pattern image. This will be the most accurate image for this magnitude local tetra pattern image. These are the top 20 most similar as well as the similar images of. These are the top 20 most accurate images as well as the most similar images for the input image, as well as the most similar images from the database for the input image provided by the users. Now let's see the overall flow of our project. At first we generated the local binary pattern in this local binary pattern, it will be carried by 3x3 matrix. From the ternary pattern, after generating this local ternary pattern, generated the local tetra pattern. So after generating the local tetra pattern, we generated the magnitude local tetra pattern. After that, the most accurate images derived from the database, so that by our proposal we can able to retrieve the similar image by means of more accuracy. Thank you.